Chapter 12, Exception Handling. This is going to be a unique chapter. We start by asking, have you ever had your program crash? And maybe some people are confused. No one's confused. We have all had our program crash, bringing back tears of maybe sadness, of perhaps anger, maybe giving up, maybe cursing, playing with the Stream Deck here. But have you had all these errors in your code and you just try to ignore it, and then all of a sudden the program gets worse and it crashes? Or perhaps those were warnings. You even have errors. This is a great meme here. Program appears to work. 50-line program, 200 errors. We've dealt with that. When a program runs and then ultimately faces what is called a runtime error, an error that actually occurs when you're running the program, what happens? The program terminates abnormally. It crashes, is what we know it, right? The program crashes. So the question that we're going to ask ourselves in this chapter is, how can we avoid this abnormal termination? How can we handle that error so that the program can either continue or can terminate more gracefully? This is what we're going to cover. But first, one more meme, a fantastic one, because how can you avoid runtime errors is the question. Here's the big brain moment of how you avoid runtime errors. You simply don't get to that point. You have code that does not compile, not even allowing you to have a runtime error. That is the big brain. So here are some objectives we'd like to cover. If you want the short story, it's basically we're going to use exception handling and try-catch blocks to handle these errors, these runtime errors appropriately. So what are exceptions? Exceptions are runtime errors. And a runtime error occurs when the program is running, and if the Java virtual machine, if it detects an operation that it's impossible to carry out. Examples we've all seen throughout the semester as we're coding up programs, and maybe we run into an array out of bounds exception, a null pointer exception. These are examples that we've seen, errors where we're running our code, program crashes, and then all of a sudden, like, wait, what happened? Oh, I went past the end of the array. For example, these are just some examples. Input mismatch exception. Maybe you're trying to read an integer, or so you tell it to scan an integer, and the user enters text, and now we get an input mismatch exception. Exception handling enables a program to deal with that runtime error and continue the normal execution, or we then terminate gracefully instead of getting, some IDE or your editor shouting at you and copying an attitude in red because you did something wrong. This is the overall idea. So when the Java virtual machine detects something abnormal, an exception is thrown from the method that causes the exception. The caller of that method can then in turn catch that exception. Those are the two words used. We throw the exception from the method where the exception is occurring, and the one who called the method can then catch that exception and can choose to handle that exception, to deal with that exception. Or it can choose to just pass the buck like hot potato, and it catches it, it's like, oh, I don't want to deal with it, and it throws it to whatever method in turn had called it. So to demonstrate exception handling, we're going to show 4 quick programs. The first program is a very basic one that will absolutely cause an exception. In fact, it could cause multiple exceptions, but we're going to focus on the exception of dividing by 0. I'm then going to show you that exact same program, but where we're avoiding the exception by using an if statement. Then I'm going to show that same program where I'm going to put that potentially bad code inside a method. We're going to offload it into a method. And then finally, that same program with exception handling in place. So here's this first program called Quotient. And if you simply notice, we're dividing right here num1 divided by num2, where num1 and num2 are user inputted integer values. So of course, if the user were to input a 0 for num2, that would have obviously be problematic. Also problematic and a potential exception would be an input mismatch exception, which would occur if the user entered anything other than an integer. But we're going to ignore that for the moment and simply focus on whether the user enters a valid number for num2 or if they were to enter 0. but we can see if they enter 0, this would be a disaster, and the program would absolutely start shouting at us. If I come over here to NetBeans, this is going to be a problem we're going to do in a few minutes. Let me just get rid of this. If I just come right here and I immediately just want to print out, 4 divided by 0, and we run this code, we're going to get an exception. What does the exception say? Arithmetic exception, right? So that is going to be a problem. You obviously cannot divide by 0. I'm going to put the code back to where it was, and we need to handle that. Well, one way we can handle it is right here with this same program. Here I called it quotient with if, and what's the difference? Is I simply use an if statement. Nothing wrong with that, right? You don't need exception handling here. I could just use an if statement and say, hey, you know what? If num2 is a 0, yeah, we're going to end up printing out this divisor cannot be 0. But if it's not equal to 0, let's perform that division and print out what we wanted to print out. And then finally, if you look at this example before I get to exception handling, what I've done here is I've offloaded this computation, this printing, and this division of num1 divided by num2. I went and I threw that into a method. So look at all of this main where I have a scanner. I prompt for the 2 integers. I scan the 2 integers. Well, here, all of that is down here in main. And then I print num1 divided by num2 is, and now I'm calling a method that is going to compute the result of num1 divided by num2. So I'm calling that method. And the reason for calling the method, that's overkill on this example. Obviously, we could have just ended right here, but this is about exception handling, right? So we're trying to guide us into how exception handling can be beneficial to us. So here, I'm offloading the code that could have caused an error, and I'm putting it into a method. And here's that method quotient where I send over num1 and num2 are the formal parameters. And I say if num2 is 0, we can't even return, right? Only if num2 is not 0 can we return num1 divided by num2. That answer would come right here, and we would print it. But what if num2 is 0? We can't even, of course, do a computation. We can't return, so we just print an error message, the divisor cannot be 0. And then what happened? We use this command system.exit, which basically just stops your program. It doesn't crash your program, it just completely stops your program in its tracks, which means, I'm going to go ahead and use a word that's going to come up in a few slides here, which means that this quotient method, it's called quotient, it saw that num2 was 0, and so this quotient method unilaterally, single-handedly decided, you know what, we got to stop this program, something's not cool, we're not going to cause a crash, but we're just going to stop the program. Did that method have the right to do that? Maybe. If you're the developer and you just wanted this method to be so strong to be able to make that decision. But that's an important discussion to come up where we discuss of who has the right to just stop a program in its tracks. Does some small little quotient method, which is doing an almost insignificant portion of a program, does it have the right to do a system.exit? Probably not. So this is not the ideal way of handling this. So as we just mentioned, if num2 is 0, the method cannot even return a value. So the method does what? It terminates the program with this system.exit. That is a problem because you should never let a method terminate the program. Rather, if here we have this main method that's called this tiny little helper method to do something, if this helper method is unable to complete its task, what's more appropriate is for it to do what? It should let the caller decide. It should tell main, hey main, you know what? You asked me to do this division. I'm having a problem with it. I want you to decide what you want to do. This is what is most appropriate. So Java enables this method to do what? To throw an exception. We can end up, Java allows this quotient method to throw an exception, which basically means to tell its caller, yo, caller, heads up. This thing happened when you asked me to compute such and such, and then that calling method would catch that exception and would take appropriate action. So the following program now uses exception handling. If num2 is 0, the method will throw an exception to the caller, and that main method uses what is known as a try-catch block. The try portion attempts to execute certain code, which may result in an exception, and then the catch portion of the code is only used if the method throws an exception that needs to be caught. That catch portion of the code will then catch that exception and will take an appropriate action. So here is the final program of this set of examples. And let me just state clearly, all of this is very overkill on this example. You would not write this exception handling and offload the quotient into its own method if this were really what we were trying to solve. It's just to demonstrate a usage of exception handling on a very primitive, naive example before we go into a deeper dive of exception handling. So here we have our main. We prompt the user, we scan the two integers, and just like before, we want to call this quotient method and get the result and then print it. But notice that now this quotient method, in this call to the quotient method, we have it inside a try block. So in this try block, and we see the curly braces, so it's a block, we have two lines of code. The first line of code is we're calling the quotient method, saving the result of that into this variable result, and then printing. So let's follow that through. So we call the quotient method, so we come up here to quotient. Imagine that all is well, num2 is not 0, so we're going to return num1 divided by num2. That returned value comes here and gets saved inside this variable result, which is then printed. All is well, and it's almost like an if-else. If we execute the try block with no problem, we don't come to the catch. And then finally, we come to this output, this print statement, execution continues gracefully. But what if when we called this quotient method, what if num2 was in fact 0? What's going to happen is we come up here and num2 is 0, so we have an if statement, num2 is 0, so what happens? Throw a new arithmetic exception with this particular string as a parameter, and notice this is an object. I'm getting ahead here, but we're actually creating a new object of type arithmetic exception, and we're calling the constructor of that new object, and we're sending over this string. And when we throw it, where does this method, this quotient method, it's throwing this exception, where does it throw it to? It throws it right here back to main, to the caller, and the main method, it catches that exception. And it saves that reference to that object that was created. We created an object. It saves the reference to that object inside the variable EX. You could have called it Bob. It doesn't matter. It's just a variable name. And then finally, we printed a message. Notice we didn't do anything with this variable EX. We could have extracted this string that was sent to the constructor of that exception object. We didn't do that. We just printed our own message. So this is the overall idea of exception handling. So let's go through some details now. The value thrown was new arithmetic exception, and we use this string in the constructor. That is an exception, and the execution of throwing, that throw statement is called throwing an exception. Now, what is an exception? It's just an object. An exception is an object created from the exception class. And this constructor, arithmetic exception with that single parameter, a string, was then used, it was invoked to construct that particular exception object. And as mentioned, we sent over this string right here as a parameter to that exception object, which just describes the exception that's happening. And so the one who catches that exception, if that caller who catches the exception wants their choice, they can choose to extract this string and use it or print it. When an exception is thrown, the normal execution flow is 100% interrupted. As the name suggests, throwing an exception, we're really going from one location of the program to another. We're leaving that method that was called, and we're now returning to the caller. The throw statement is really analogous to a method call. But instead of calling a method, that throw statement calls what? It calls a catch block. And think of that catch block as analogous to a method definition with a parameter that matches what is being thrown. So you're going to see in just a bit when a method encounters an exception, it can not only throw one exception, it can throw a variety of different exceptions based off of the exception that occurred. And so we have to match up the exception type that was thrown to the catch block. You can catch different types of exceptions as well. That's just getting ahead, but I'm planting that seed. Now the difference though, so even though we say that the throw statement is analogous to a method call and the catch block is analogous to that method definition, the difference though, unlike a method, after the catch block is executed, the program of course does not return to the method that caused the error. That would be a disaster. Instead, after the catch block is executed, we simply execute the next statement after the catch block. So here I simply mentioned that identifier EX in the catch block header. It's just a variable and it acts like a parameter in a method. And this parameter is referred to as a catch block parameter. The type that precedes the parameter, such as input mismatch exception, index out of bounds exception, arithmetic exception, that simply specifies what type of object was actually created and thrown so the catch block can catch it accordingly. And then once the exception is caught, you can access that thrown value from the parameter of the catch block. So in summary, here's a template for a try, throw, catch block. We have try, we have some code we're going to run. Then we're going to have some statement or a statement or statements that may throw an exception. And then we're going to have more code to run. You might have, in your try block, you might have hundreds of lines of code, thousands of lines, maybe. You could have just a few lines, but one or more of them may cause an exception. And then as a result, we have to have a catch block that will catch that exception that is thrown and then have some code to either process that exception or, using that phrase, hot potato, pass the buck, pass the exception, even back to someone else, and we'll cover that. So what's the value of exception handling? In general, a method has no right to unilaterally determine how to handle an exception. If an exception occurs, the method should not attempt to deal with that exception themselves. Rather, if an exception occurs and you were called to do something small, instead of just saying, well, I'm going to end the program. What a disaster if we allowed methods to do that. Instead, the method should do what? It should contact the caller that called them, let them know, hey, heads up, an exception occurred. You handle it because you asked me to do this small task. I'm not going to go just cancel the whole program. So here I was unable to finish what you asked me to do. You decide how best to proceed. Allow the caller to do that instead of the method to do that. That is the real value. So the short answer, exception handling enables a method to throw an exception to a caller, thereby allowing the caller to handle the exception instead of the method. Without this capability, the method itself would have to handle the exception or terminate the program, and think of this as like way above its purview or its pay grade, because obviously a method has no idea what to do in the case of an error. And a good example would be library methods. A library method can detect an error, but it doesn't know what you want to do, so it's going to throw an exception, and then it's going to allow you to deal with that error. So the key benefit is to separate the detection of an error from the handling of an error. An example, I mentioned the library methods. So the following code is going to attempt to read an integer from the user using nextInt. But of course, we've seen if the user enters anything other than an integer, it will give an input mismatch exception. So instead of just having the program crash with this input mismatch exception, we're going to deal with that inside a try-catch block. So here we have this class input mismatch exception, a scanner, and we have this do while loop. We're going to keep on looping as long as continue input, which is a Boolean variable. As long as it's true, we're just going to keep on looping. What do we do inside the loop? We have a try statement, a try block, and we print enter an integer. We scan that integer with nextInt, and this right here, it's in green, it may cause an exception if the user enters something invalid. Let's pretend for kicks that they entered an integer, we would simply print the entered number is, and we print out that number. We set continue input to false, and so this will be false right here on the while statement, and we exit the loop. But what if when we try to scan input.nextInt, here we're calling a method, right? This is a method, an instance method of this scanner object that was created from the scanner class. So when we call this nextInt method, imagine we're doing a huge program. We're in the middle of running something profound. I don't know what it may be, but we're running something significant. And we get to a small part of the program where we have to ask the scanner to scan an integer. And the user maybe inadvertently, accidentally types a W instead of the 2, and they hit enter. Imagine what a disaster if we just crash after running that program for 10, 15, 20 minutes or more, trying to do something significant, and now it crashes because we asked nextInt to scan an integer. It could not. Granted, it's the user's fault for typing a W, but what a disaster that we allow nextInt to just crash our program. That would be horrible. So instead, what we want to do is we want nextInt to do what? To throw an exception, which it does. It actually throws the exception, so it's not its fault. It didn't crash the program, but we would not have handled that exception, which is what we're doing now. Now we're handling the exception. So nextInt, if the user typed, as I mentioned, a W, well, what happens here is it will see, whoa, that's a problem. And so the nextInt method will throw an input mismatch exception. Right here, that exception will occur and be thrown. And so now we have a catch block that catches that exception. And we print, try again, incorrect input, and integers required. And then we use this input.nextLine just to disregard that new line, right? And we start over and we come back to the try block, rinse and repeat. This is an example of dealing with that input mismatch exception. Here in this slide, we're seeing the different exception types. This is just a bird's eye view. Let's come to the next one. We have system errors. The system errors are errors that are thrown by the Java virtual machine, and they're represented with this error class. We have virtual machine error, linkage error, other things that are beyond the scope of what we're covering. These errors rarely occur. And even if they did occur, there's very little we can do about them. But it's important to at least mention that within object, within throwable, we have the error class and we have exception class. Not much we can do about errors if they were to occur within that error class. Exceptions, however, they describe errors caused by your program as well as by external circumstances. These errors can be caught and handled by your program. Now notice a subclass under exception is called runtime exceptions. These are the exceptions that occur during the execution of your program. Input mismatch exception, arithmetic exception. We've seen plenty of null pointer exceptions, right? And I can cry about that. I've seen way too many myself. These are exceptions that occur during the execution of your program. What we want to see here is the idea of what is a checked exception versus an unchecked exceptions. Unchecked exceptions, as well as their subclasses. We're talking about runtime exception, error, and their subclasses. These are all known as unchecked exceptions. Java does not force you to deal with what are called unchecked exceptions. And the reason why, because there's a lot of them. And if Java forced us to deal with unchecked exceptions, meaning all these runtime exceptions, so any of these null pointer exceptions, index out of bounds exceptions, Java's never forced you to deal with them, which is why your program has crashed when you've had those issues. Java does not force you to deal with it. And the reason Java does not force you to deal with those exceptions, meaning to handle them and take care of them within a try-catch block, because if Java forced you to use try-catch blocks to possibly handle every single index out of bounds exception, every single null pointer exception, your program would be littered, would be flooded with all these nasty try-catch blocks everywhere. So Java does not force you to deal with those exceptions, which is why they are called unchecked exceptions. However, there are checked exceptions. And these checked exceptions, it's a different class of exceptions. These checked exceptions are such that Java forces you, the developer, to deal with these exceptions. So again, the unchecked exceptions, they're exceptions, or they reflect programming logic. They reflect errors in programming logic. And so the null pointer exception, index out of bounds exceptions, these are logical errors that will occur within your program. And they can occur so often that, once again, Java does not force you to deal with them, because again, you would have a nasty, ugly program that's just cluttered with all of these try-catch blocks. So these are your unchecked exceptions. We have the error class and we have runtime exceptions. These are the exceptions that you do not have to deal with. You're not forced by Java to use try-catch blocks to avoid these type of possible exceptions. But we then do have checked exceptions, which are required for us to handle. A major class of checked exceptions is with I/O handling, input-output. If you're reading from a file, Java requires you to deal with that exception. You cannot read from a file without saying that, hey, I might cause an error, and you have to throw an exception, or a more specific, file I/O exception. So those are checked exceptions that you absolutely must deal with. Let's practice a problem. Using the two arrays shown below, here we have this string array called months, and we have an integer array called DOM, which is simply showing the number of days of a given month, right? So we have 31 days in January, 28 days in February, and so on. And here are the names of the months. So we want to have these two arrays. We want to ask the user to enter a number between 1 and 12, and then simply display the months and the number of days corresponding to the integer of that month. That's pretty easy, right? So let's just prompt the user, enter a month number 1 through 12. And let me even pause for a moment to say that, so of course, I've gone ahead and made this class to save time. It's called print month demo. I'd pause the video. This is going to be a really short example. We're going to be done within just a few minutes, 5 minutes max. So this is a shorter video. Go ahead and pause this, type up these two arrays, won't take you too long, and then come back and follow along. So I'm prompting the user, enter a month number. Let's scan that month number, and let's call it, what do I want to call this? Month, sure. Month num, I'll call it month num, equals input dot, I want to do in, dot next int. I'm going to come up here and change this to in. And month num, of course, I need to declare that. Int month num equals in dot next int. And now let's print the results. So here I'm going to print, oops, I typed that wrong. Well, let's do it again. System.out.println, and let's type the month you entered is %s new line, %s new line, and we want to simply, if they entered a 0, or if they entered a 1, it's for January, which is at index 0. They entered a 2, they mean February, which is at index 1, right? So we need to print the months array at some index. Which index? Month num minus 1. Of course, this is a printf. And let's now also print system.out.printf again. The number of days in the month is, boom, %d new line. And here we want to print num days and simply put here month num minus 1. Let's run this. So enter a month 12. The month you entered is December. The number of days in the month is 31. I don't even like that. The number of days in %s is 31. I want to put December again. Just looks better. And I want this to be on the same line. Let's run that again now. Enter the month number 2. The month you entered is February. The number of days in February is 28. Fantastic. Let's do another one. 12. The number of days, the month you entered is December. The number of days in December is 31. January looks good, right? These all should be fine. Here's July. Fantastic. Let's do March, since I'm looking and we're in March right now. So all is well, right? Until what? What if the user is a genius and they put 0? Array index out of bounds. Or if they put 13, array index out of bounds. That is a problem. How could you deal with that? If you wanted, how could you deal with that with exception handling? What would you include in this code? Pause the video. Think of what you would try to include, where you would put a try block, and where you would put a catch block, and how you would take care of that. So what we could simply do is all of the code that will possibly cause an exception, which is this right here, try, and then let me come over here and put a catch. Check this out. So I'm going to go ahead and auto format, but let's even do this. Just do this, try tab, and notice it's fantastic. It does all that for you. You can then take your code and put it inside the try block. Now let me do a format. So here we're saying that, hey, I have this try block, and I want my catch on the next line. I don't like my catch there. I want my catch right here. That's just how I like it. So I want to, that's going to be an auto format. I want to see if I can fix that really quickly. Tools, options, editor, and this is going to be on formatting, and this is under Java, alignment, catch. There we go. So under alignment, catch, and so now I can do a format and catches on the next line. I prefer that. I think it's easier to see it. So here's the try block. This will result possibly in an array index out of bounds exception. So I'm not going to catch this exception. I'm going to catch this one. Now, just catching exception is more vanilla and allowed, and we'll cover that on a future video. But here, let's catch the exact exception, which is array index out of bounds exception. Notice NetBeans called the name of the variable E. That's fine. I like EX better, standing for exception. I mean, E stands for exception as well. If you like E, no harm, no foul. You're just, that opinion is not really accurate. That's a joke. So all we do now is inside this catch block, we simply put some print statements. You entered an invalid month number, and we can just say you must enter an integer between 1 and 12 inclusive. We'll even tell them inclusive in case that much wasn't clear. So now simply look at what happens when I run this code. Run it with, again, a 1, fine. Run it with a 12, fine, right? We come run it with something else, a 13, and now we don't crash. That's a big deal, right? It hurts my feelings, right? I say jokingly when Java starts shouting at me in red and telling me I have a small brain, which I do have small brain way too often, right? That happens. It's human nature. We make mistakes, right? Java shouting at me. Well, now I've avoided that. Java's no longer shouting at me. Instead, I am handling the exception. So this next int, right? But we're not even dealing with the next int one. Right now, the exception's happening really right here. We're dealing with this exception of trying to maybe access an index that is out of bounds. So we're dealing with that exception. It's being thrown potentially, and we're catching it, and we are dealing with it. So what if we wanted to just force the user to keep doing this over and over? I'll do that same do while loop. So I'll do a do tab while, let's call this Boolean flag equals true. While flag. It's a common way of having a variable called flag. We set it to true or false to know when we can leave our program. So here I have a do while loop. I put that entire try catch block in the do loop. So if it works and we have no error, I'm going to set flag to false. That's all I'm doing. Set flag to false to exit the loop. Otherwise, if we never make it to here, it never is false, and we'll just keep on looping over and over and over and over. So let me put a new line here, and let's run this code now. Enter a month number. Sure. 14. Nope. Okay, 0. Nope. 52. Nope. How about 8? Fantastic. You entered August, the number of days, and August is 31. We come back to here. This is a similar code shown on the slides. And guess what? We are done. Let's go. 35 minutes. It's been fun. Not a lot of code here, but a lot of concepts, right? A lot of new concepts, new terminology, things that we're seeing, we're hearing, we're seeing, but we're not maybe kicking the ball with because it's just concepts that we need to understand and use when necessary. So you really want to go review those things to make sure you're solid on them. Feel free, reach out, ask questions, leave a comment. As always, it's been fun. Take care, everyone.